Hi everyone, welcome to my YouTube channel, Know About Embedded System. So in today's video, we will understand one of the important protocol that stands for CAN. The CAN stands for Controller Area Network. So you guys already knows that this CAN protocol widely used in the automotive industry or in our automobiles or in our cars. So in today's video, we will understand what are the core features of this CAN protocol and how we're able to use this CAN protocol in our automotive. That part we will understand. So before starting the video, if you're a new viewer to my channel, please subscribe my YouTube channel and gain the knowledge on embedded system. So guys, so when we say CAN, as already I told you, CAN stands for Controller Area Network. This is the full form of your CAN, Controller Area Network, and you know that already CAN protocol widely used in our cars. If you take any example of our car, so we are going to use the CAN protocol in order to communicate between two different ECUs. So if you take any car if you take a moderate cars, medium range cars, you will find at least 8 to 10 different ECUs. And if you take a modern cars like Audi, Benz and so on, so more than 20 different ECUs you will find. So how the communication will happen between these ECUs? The communication will happen with the help of CAN protocol. So CAN protocol plays a very important role in our ECU communication, ECU to ECU communication. Now, so who has invented this CAN protocol? So CAN protocol is designed and developed by Robert Bosch in 1986 in order to provide a solution for the ECU communications, especially in the vehicles, automotive industry. In order to provide a solution for ECU to ECU communication in the vehicles in 1986, Robert Bosch developed and designed and developed. So not only automotive system, it is used in the regular our embedded industries and medical industries also. The CAN protocol is used. Okay, so this is a very simple thing you should know. Robert Bosch in 1986 they have invented. Now what are the core characteristics of your CAN protocol? So this is a very important thing you should know before going to any interview. You should know the core characteristics of CAN protocol. There are many important features are there, but out of that I have taken very important one, which are very useful. The first important characteristic of CAN is basically message-based protocol. The first point you can see here, CAN is a message-based communication protocol. That means each message is identified by unique ID. Each message in the sense frame. I'll just show you how it looks like. So when I say a message, you can see here. So message is nothing but a frame. So data is identified with the unique ID rather than node address. If you consider our I2C communication protocol, we're going to use slave address as a communication, or slave address we're going to use to communicate with the slave and master, right? But in case of CAN, it's not like that. So we're going to use message ID, or you can say frame ID. We're going to use message. You can see here. So this is my simplified frame structure. In this simplified frame structure, we will have a message ID here and control field, data and CRC and identifier. This is a very simplified frame structure, and important parameter here you can see the message ID. Every message or every frame will have its own identification number, and with the help of this we're able to communicate. This is a very important thing, one of the important feature of our CAN communication protocol. The second important thing you can see, CAN will be a multi-master communication. CAN is not like master-slave communication, but instead of that, CAN is going to communicate as a master-to-master communication. So each ECU, you can see this diagram here. Each ECU, these are all ECUs, transmission control, engine control, ABS, and so on. These are all our ECUs, and each ECU is playing as a master. And this line, green color line, whatever you're seeing here, this is our CAN network. With the help of this CAN network, each ECU is able to communicate, and each ECU is going to be acting as a master. That is why CAN is also support CAN always supports multi-master communication. There is no master, no ECU is a master, no ECU is a slave here. Every ECU is a master here. So this is the second important feature you should know about the CAN. The third important thing, the CAN uses a differential signal. You can see here what they are saying here. The CAN protocol uses two wires, namely CAN H and CAN L. This is also important thing you should know. CAN uses two wires, or you can say twisted wire we are going to use to communicate. You can see in the diagram here. So the blue and yellow color line, CAN H and CAN L. We're going to use two wires, namely CAN H and CAN L in the communication protocol, and we're going to use different signal mechanism. So what is this? I'll explain later in the upcoming videos. Just try to understand here. CAN protocol uses two wires, CAN H and CAN L, and it is going to use something called as a differential signal. Okay, what is that in detail? I'll explain later in the upcoming videos. Okay, so at this moment you can just understand we're going to use two wires, CAN H and CAN L, currently what you're seeing on the screen. The next point, CAN uses non-destructive arbitration process. So next point, whatever you are seeing, non-destructive arbitration process, CAN protocol uses a priority mechanism. That priority mechanism is derived from arbitration process. So in I2C, we have also seen arbitration. Even in CAN also, there will be arbitration. In order to get this arbitration, we're going to use a message ID. You can see here, node 1, node 2, node 3. Node 1, nothing but ECU1 is sending some message ID, ECU2 is sending some message ID, and ECU3 is also sending some message ID. So which message has to be prioritized? Very simple. Whichever is having the lowest number, that message will be getting prioritized. So in this example, B3 is the lowest number, right? So if you compare, like, it is going to perform a bitwise operation inside. So bitwise arbitration will take place in case of CAN protocol. So you can see here the lowest number will have highest priority, and that particular message will win the arbitration, and that particular message ID will get prioritized, whenever you're transmitting more than one message. Okay, this is also one of the important feature which is available in the CAN, and this is also this is how the CAN is going to prioritize the different messages. Now, along with that, we have some more important features you should understand. CAN will support high speed and low speed as well. So why we have to use CAN? So this is also one of the reasons. So CAN will support 1 Mbps speed as a high speed, and also it will support 128 kbps speed. Both it is possible from the CAN, and we are able to transmit 8 bytes of data. This is also one of the important characteristic of the CAN. So now next point is CAN FD. So we have something called as flexible data rate, and using this flexible data rate, we can able to transmit up to 64 bytes of data and 8 Mbps speed. This is a very big advantage of a CAN protocol. So you can see here 8 Mbps speed and up to 64 bytes of data transmission. Right, this is also one of the important feature you should know. The next one is error handling mechanism. One more biggest advantage with the CAN is the CAN protocol is capable of handling the errors. Whenever there is an error in the network, CAN protocol is designed in such a way that it is going to identify what type of error and how to recover from that error, and how to manage other networks whenever there is an error scenario. So this mechanism is available in the CAN protocol. How, that I'll explain later in upcoming videos. The next important point is sleep and wake up mechanism. The CAN protocol, if there is no communication in the ECUs, or if there is no communication, data transmission and reception is not happening, then ECU will go to the sleep state. ECU will enter into the sleep state, and power consumption also is going to be optimized whenever you're going to sleep state. And as soon if you want to transmit any message, or if you want to receive any message, immediately ECU will wake up. That's why. So this feature is also added in our CAN sleep and wake up mechanism. So this is also one of the important thing you should know. So these are all important points or core characteristics of your CAN protocol, and you should know before going to the interviews. I hope you are clear with these points. So what are the CAN protocol variants? This is also you should know before going for any interviews. So what are the different variants available in the CAN? There are three different variants available in the CAN. One is called classical CAN, or it's also called as standard CAN. We will call classical, standard CAN, and we have CAN FD and we have CAN XL. There are three major variants which are available in the CAN. So this CAN, nothing but a standard CAN. You can see here what is the speed and what is the payload. From the classical CAN, or it's also called as standard CAN, the maximum speed up to 1 Mbps. The speed will go up to 1 Mbps, and you are able to transmit a data up to 8 bytes. You are able to transmit 8 bytes of data with respect to classical CAN. And what type of application you're going to use? You're going to use applications like small cars where there is no much complications will not be available. In such cars we'll be using, and we'll be using in a two-wheelers we'll be using, and applications are not which are not much complicated. We still will be using this CAN, but non-complicated applications will be using. So this is your CAN. The second one, CAN FD. CAN FD stands for flexible CAN flexible data, right? What is the advantage? You can see here up to 8 Mbps speed you are able to transmit data, and up to 64 bytes of data you are able to transmit. In previous case 8 bytes, and in CAN FD it is 64 bytes. And almost all modern cars we are going to use your CAN FD. Whatever any car if you take, so if there is an automotive system, then definitely we're going to use CAN FD. All types of complicated, non-complicated, simple applications will be using CAN FD. The last one is CAN XL. So this is called CAN extra large. And what is the advantage? Speed you can see up to 20 Mbps speed, and the data transmission you can see 2048 bytes in a single transmission. So this is a very big advantage of CAN XL, where we can able to achieve speed of 20 Mbps and up to 2 kilobytes of data, 2048 bytes of data, and it is used to make a bridge between Ethernet and CAN. This CAN XL protocol is used to connect between CAN and your Ethernet. So these three are major variants of your CAN protocol. I hope this video is an informative video. So if you feel this video is an informative video, please click on like button and subscribe my YouTube channel.